Okay, so we're going to talk about the most important shape in geometry, which is triangle. And so we're going to talk about triangles and their angles. And our essential question and our goal is to classify triangles by their sides and their angles, and then also to find some angle measurements of some triangles. So, this is kind of easy. A triangle is a figure formed by three segments joining three non-collinear points. So the three sides are the segments, and then these are non-collinear points, right? So each corner, those points are called vertex, or together they're called vertices, right? The adjacent sides are two sides that are intersected, or they have a common vertex, right? And then the legs of a right triangle are the two sides that are next to the right angle, or the two sides that form a right angle. The legs of an isosceles triangle are the two congruent sides, right? So those are some of the terms that you should already be familiar with, right? And so we already talked about the legs. The hypotenuse of a right triangle is the longest side of a right triangle. So the two shorter sides are the legs. So the hypotenuse is the longest side. It's always opposite to the right angle, right? So if you have an isosceles triangle, so the base of an isosceles triangle is the third side that is not the two isosceles sides. So I drew the picture here at the bottom, but you can draw the triangle sideways. And so the base of a isosceles triangle sideways will be actually over here on the right side. So if these two sides are isosceles, then the base, so it's not always at the bottom, it's just the third side that is not congruent, right? So the interior, as we talked about before, is the inside angles. So the interior angles are the angles that's inside the triangle compared to the exterior angles. So the exterior angles are if you were to extend each side of the triangle like this, right? The exterior angle is the angle that's outside of the triangle like this. So interior is the inside, exterior is the outside of the of the any triangle, if we were to kind of extend that on each side. Now, corollary is similar to axioms and postulates, except the corollaries come after the theorems, or it follows theorems. And so it's something that's kind of obvious from the theorems. So we had axiom and postulate that we just took it as facts, and that was even before the theorem. But once we have the theorem and once we know the theorem is true and we proved it, then corollary follows the theorem, and we just take that as facts and true as well, and we use them. Okay, so those are some of the vocabulary words that we're going to be using, although some of them should be pretty familiar to you already. All right, so how do we classify triangles? Well, we can classify triangles by their sides, and we could classify the triangles by their angles. Now, some of them kind of overlap, but then you could have two different names for each triangle. One name according to how the sides are compared, and then the another name how the angles are compared. So equilateral triangle just means, just by like the way it sounds, all three sides are congruent, right? Now, equilateral triangle, another name for that is actually equiangular triangle. So equiangular means all three angles are congruent. Now, so they're kind of saying the same thing in a different way, because when all three sides are same, all three angles will also be congruent as well. So that's kind of interchangeable, but we're talking about the sides here, right? We're talking about the angles for equiangular triangle, right? Now, isosceles triangle, now you might have heard or thought the isosceles triangle was two congruent sides, but it's actually not a completely accurate description of isosceles triangle. The key phrase here, or the words here, is at least two congruent sides. So we have these two sides that are congruent. That's obviously isosceles triangle. Now, if the isosceles triangles, if the two sides are congruent, then you will also get the two base angles. These are called base angles. And so if two sides are congruent for isosceles triangle, then the two angles are also going to be congruent on the base angles there. Now, because it says at least two congruent sides, so this is isosceles. However, the equilateral triangle can also be called isosceles triangle because this one has three sides that are congruent. Well, three sides means that at least two of them are also congruent as well. So this equilateral triangle can also be called isosceles triangle. So all equilateral triangles can also be called isosceles triangle because at least two of them are congruent. Well, we know all three of them are congruent, but as long as two of them are congruent, we can call that isosceles as well. So all equilateral triangles are isosceles. However, not all isosceles triangles can be called equilateral, right? Because, when only two of them are same, then it's just isosceles. When all three of them are same, it's equilateral, right? Now, scalene, as I marked right here, just in case it wasn't obvious, all three sides are different, right? So you got one slash, two slashes, and three slashes. So that means no sides are congruent, and so that's scalene. Now, similar to the sides, we have some names for angles. So when all three angles here are less than 90 degrees, they're all acute, right? So that's acute, acute, acute. So you got three acute angles, so that's acute triangle. Now, we already talked about equiangular, where all three angles are congruent. Right triangle means that one angle is 90 degrees, right? Then obviously the other two are acute angles, right? Obtuse triangle means one angle is obtuse, however, the other two have to be acute, right? So those are names. You could have at least two names for each triangle, one by looking at the sides, one by looking at the angles, right? All right, so let's take a look at some of these. So if I have a triangle like this, right, this is a right angle, right? So this is a right triangle, but I also have a slash here, and then I also have 45 degrees, 45 degrees. So not only those two sides are congruent, but those two base angles are also going to be congruent. They're always going to be the same. When the two sides are same, making it isosceles, then the two angles are also congruent. So this is a right triangle as well as isosceles triangle. So you put them together. So this is right isosceles triangle, right? This one, the 130 degrees is obviously obtuse, right? That's a one obtuse angle. And then these two are acute, but we don't know what they are, but it doesn't matter. So that's obtuse. And then all three sides are different length. So I marked it 1, 2, and 3 slashes just to make it obvious. So this is obtuse and scalene triangle because all three sides are different length, right? So each triangle that you see will have at least two names, right? One referring to the angle, the other one referring to the sides. So you should be able to classify any triangle with at least two names, right? Now here's our first theorem for the chapter 4. So this is a triangle sum theorem. So sum means we add, right? And you should already know this, but if you add the measurement of angle 1 and measurement of angle 2 and measurement of angle 3, whether they're same or different, they're always going to add up to 180 degrees. So any triangle, doesn't matter what size or what shape, if you add all three interior angles, it's always going to add up to 180 degrees. That's a very important fact and information that you should already know and to remember going forwards. That's the triangle sum theorem. Adding all three angles is always going to be 180 degrees, right? Now, similar to that, there's an exterior angle theorem. So this is a little bit confusing because here's a triangle, and if you extend any one side of the triangle, so if I extend the bottom one here, right, there's an angle that's outside of the triangle. So that angle 1, whatever that may be, so just to make it a little bit easier, I named that 130 degrees. So that's an exterior angle, right? What that means is that any exterior angle, whether it's here or if I extend it here, if I extend it here, that is always going to be equal to the measurement of the other two angles. Now that's called the non-adjacent interior angles. Now, it's also called the two remote interior angles. So whether you call it non-adjacent interior angles or two remote angles, right? What that means is that if I have an angle 1 here, angle 50 is going to be adjacent because it's next to it, right? Because that's linear pair. So if this is 130, that's going to be 50. Well, since I know triangles add up to 180 degrees, if this is 50, the other two have to add up to 130. So I just made up some numbers here, 60 and 70, to make it easier. But if I add 60 plus 70, doesn't that also equal to 130? Because 130 plus 50 has to be 180, and then 130 for these two plus 50 has to also be 180. So that's the kind of related to the triangle sum theorem, but that's called the exterior angle theorem. So any exterior angle on the outside is going to equal to the two non-adjacent, so not the one that's next to, but the two that's far away. So it's also called a two remote interior angle because remote means kind of far away. You know how you have a remote control that controls things from far away. So those are also called the two remote interior angles. So then here's a corollary. Now it says corollary to the triangle sum theorem, but it could also be corollary from the exterior angle theorem because they're kind of related. So that follows those previous two theorems. And so the corollary to the triangle sum theorem says that if I have any right triangle like this, right, then if I add the two acute angles, it's always going to add up to 90 degrees. Well, that kind of makes sense, right? Because since triangle is 90 degrees, well, these two have to add up to 90 degrees. So 90 plus 90 has to add up to 180 degrees. So it kind of follows the triangle sum theorem. Now, it also follows the exterior angle theorem, because if I look at the exterior angle here, well, exterior angle here is 90 degrees as well, right? Because that's the 90, so the other side has to be 90. Well, then, since that's 90, then these two, according to the exterior angle theorem, right, the two non-adjacent interior angles or the two remote angles have to add up to 90, same as this one. So it follows both the triangle sum theorem and the exterior angle theorem as well. Okay, so that's the corollary, which is following the prior theorem that we just looked at. All right, so then with that information, let's take a look at how we can solve a problem like this, right? So we have a triangle here, right? And we have the exterior angle here, which is described as 2 times x plus 4. And then these are the two non-adjacent. So this angle here is the adjacent, right, to the exterior angle. So these two are the two non-adjacent, or it's also called the two remote interior angles because it's far away from this exterior angle, right? So then according to the exterior angle theorem that we just looked at, the exterior angle here is going to equal to the sum of these two angles. So if I add x plus 50, that's going to equal to the outside, the exterior angle, which is 2 times x plus 4, right? So you make these two added together equal to the exterior angle on the outside, right? Because they're always going to be the same according to the exterior angle theorem, right? So we just solve this, right? So we distribute this, right? So you get 2x, and then distribute this, so you get plus 8, right? So then what we want to do is we want to combine like terms, right? So then we subtract x here to cancel that out, and then we subtract, let me just show you the work here. So we subtract x there, and then we can, let me show you the work here at the bottom here. So then you get 50 is equal to 2x minus x is 1x, or just x, plus 8. And then we move the 8 to the other side, so we subtract 8 on the other side. So then x is going to equal to 58, right? So we got x as 58, but we're not done with just x because we're trying to find the value of x, and we're going to use that to find the exterior angle on the outside, right? So we're trying to find the measurement of the exterior angle. So we have to plug it back in into the x here. So x is 58, so plug in 58 into the x here. So that's going to be 2 times 58 plus 4, which is 2 times 62. And so 2 times 62 is going to be 124. So the exterior angle is going to be 124 degrees. Okay? So that's how we use the exterior angle theorem to solve for the x value first. And then after we um, solve for the x value, then we plug it back in to find the measurement of the exterior angle there. Okay. All right. Next one. So let's do a couple more examples, kind of similar to what we just talked about here. So we're going to classify the triangle by its angles and its sides, right? So the angles, this is a right angle here, right? And then these are 54 degrees and 36 degrees, so they're all different. So that means these segments are going to be all different length, right? Because the angles are different, right? So then this is a right and scalene because all the sides are different length because all the angles are different, right? So this is a right scalene triangle, right? So you can have two names, one referring to the angle, one referring to the sides there, okay? Now, so here's another example to find the measure of the exterior angle. So again, here's the exterior angle, which is 3x plus 10. So 3x plus 10 is going to equal to the sum of the other remote or the non-adjacent. So here is the adjacent right here. So then these two are the non-adjacent. So we add those together. So x plus 70. And then we solve this for the x and then plug it back in to find the exterior angle. So we subtract x to cancel that out here. And so then you get 3x minus x, which is 2x. And then plus 10 is equal to 70. And then we subtract 10 to cancel that out. So then we get 60. And we're left with 2x here. So then we divide by 2 to cancel that out because this is 2 times x. And so then x is going to equal to 60 divided by 2 is 30. So x is 30, but we're not done with that because we have to plug it back in here because we're trying to find the measurement of the exterior angle. So we plug in 3 times 30 for the x, which is 90 plus 10. So that's going to be 90 plus 10. So that's going to add up to 100 degrees for the exterior angle. Okay, so that's how we use the exterior angle theorem because the outside angle here, the exterior angle, is going to equal to the sum of the two non-adjacent, which means the two angles that are not next to the exterior angle there. Okay, all right. So then that's the homework. So thank you.